Amber.
Oh, yeah.
Letter D. Could you tell me what goes in the first oval?
Yeah. 1, 2, 3.
Yes, the domain. It's that simple. And Nakia, could you tell me what goes in the second oval? And Sue, the one maps to or connects to what? 10. How about the 2? 15 and 20. And the 3, 25. Good. Question.
Yeah, do you have to put arrows or is it
Arrows are not necessary. Okay, I think you guys can handle the graph. This one will rescale because we have to go up to 25. So maybe I'll go in 5s on the y-axis. And then for the x-axis, I can just go in 1s. So 1, 10, 2, 15, and 2, 20, 3, 25. So feel free to rescale if you need to. Celine, the domain for this one?
1, 2, 3.
Good. And Nikki S, the range?
10, 15, 20, 25.
Thank you. Gabe, is this a function?
No. It fails vertical line test.
Good. So you get a vertical line that can cross through more than one point. It is not a function. Any questions on D? Very well. Letter E. We have a sideways parabola. So there's an infinite number of points here. So whatever you write here, I would put it in interval notation. It's not just a set of numbers like you had for the previous examples. I saw some people do that when I was walking around yesterday. Allie, could you tell us the domain for letter E?
1
And what's the symbol next to the 1? Bracket.
A graph.
Okay. So if you go from left to right, this is what I do when I find domain and range when I'm given a graph like this. For domain, I hold my pencil vertically and I go from left to right and I locate where the function or relation starts. So it starts here at 1. And because there isn't an open circle there, that means that it can equal 1. So that is the lowest x value that's possible for this relation. And then I continue and I look for any gaps. I don't have any, like the graph is touching my pen or pencil right now, so I have points, I have points, I have points, I have points. And then what's implied here is that this continues. So as Ellie said, this is going to go to infinity, and you can never equal infinity, so it always gets parentheses. Any questions on that? Okay, Nikki B, the range.
10, 15, 20, 25.
Letter E.
Yeah. No, wait. E?
Yes.
Oh, sorry. -8. No. Negative infinity and infinity.
Yes. So these arrowheads imply that this function or relation is going to go all the way in this direction forever, and also down and down and down and down and down. So it's going to continue to spread out. So what I do when I'm finding range with a graph is I often take my pen or pencil, make it a horizontal line, and then go up from the bottom. See, I have points, 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 points. Like there's no jump, there's no gap. And again, because of the arrowheads, it's implied or assumed that it just continues. So this thing can produce any y value. We assume at least. Any questions on E? Oh, we're not done yet. Dan, is this a function? This is not a function. And tell us why? Fails the vertical line test, yes. For a given x value, for example 5, we get 2 y values out. This one and this one. We don't like that to happen, with functions at least. Okay? Letter F. So it's just this horizontal line here. Dominique, could you give us the domain? Thank you. Okay, so this goes forever in both directions, negative infinity to infinity. And Chowan, could you give us the range? Oh, not here. Jen, could you give us the range? Okay. So if you do it this way, hold your pen or pencil horizontally, start from the bottom, which would correspond to negative infinity. Move it up, look for where it touches the graph. Nothing, 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 and then something. So what is the y value here, Jen? No, it's one particular number. Oh, I'm sorry, I did not hear you. Okay, so what is the range again? 3. And how could you express that?
3, comma. No, wait, no. It's infinity, comma.
No, it's just 3.
Okay.
So,
You're doing this on purpose.
okay. So this is an interval notation way of expressing 3 to 3. Also, if you want to use set notation, because I didn't dictate to you that you had to use interval notation, you could just use the curly braces and put a 3 inside. Val, is this a function?
Yeah.
It is. Good. Any questions on F? Okay. Number 2. U and J, is y equals x squared a function of y in terms of x? Yes, it is. You can write it as a function in terms of x. You could write it as f of x equals x squared. That's an indicator that it is a function in terms of x, because the x can be inside the parentheses here. Thank you. Terry, what is the domain of this function? 1, 2, and 3? Okay. There are many more possible x values. And yes, there's an infinite number. So you can say it's all real numbers. You could also use interval notation. Dan, can you read what I'm writing? Okay. I just want to make sure it's large enough. Yeah. No, unless somebody tells you, you must use interval notation. Yeah. Jessica, the range? 249? Okay, so there are many other numbers that are possible y values in this relationship y equals x squared. You gave us 3 of them. What might help you is to look at the graph. You could use a computer, a mobile device, graphing calculator. I'll use the graphing calculator, and I'll graph y equals x squared. I'll just use a standard zoom window. Okay, so if you follow my strategy of before, for range, holding your pen or pencil horizontally, scrolling up from the bottom, what's the first y value that this thing produces, Jessica? 0. So we can use interval notation here and say bracket 0. And where does it go to? Infinity. So what this means is all real numbers from 0 to infinity. Or in other words, this thing has y values that are non-negative. Notice that there are no y values underneath the x-axis. Okay? And we actually, or I actually did this part here. This is the function notation, f of x equals x squared. And I showed you the graph. on the calculator. Any questions on 2? I put this packet together to give you extra practice, make sure we covered all the essential topics in this appendix. And I'll assess you on these topics on Tuesday, so make sure if you have any questions to ask them as soon as possible. Number 3, random helper. Brett, is x equals y squared a function of y in terms of x? It is not. You could not write this in f of x notation. You could write it in f of y notation, but that's not what it's asking. Julia, the domain? Bracket 0, comma, infinity. I believe that to be true. So for this one, what you can do, if you're not understanding, is make a t-chart, maybe. Plug in a value for x, 0. What does y have to be? 0. If x equals 4, what is y?
2.
And? Very good. If x equals negative 1, what is y?
1 or y.
Plus or minus I, but we're going to remain in real number land. Okay? So you're not going to have any x values that are negative if you're remaining in real number land. And when we're talking about domain and range, that's what we're talking about. Like what values leave us in real number land. The graphing calculator, unfortunately, cannot accept something that's x equals. You could write it in terms of y, like y equals plus or minus what? You tell me. Square root of x. So you could graph those two separate things with the calculator. But some of these apps that you can get are able to do this. So I'll show you. Like this one here, which I think you can just search for a free graphing calculator and find it. So let me clear this. So I can type in x equals, hopefully, oh, it's set it equal to 0. So it's actually x minus y squared equals 0. I use my algebra skills. That's how I pay the bills, literally. So what's cool about this is that you can use your fingers to manipulate it. And hopefully you can start to see it. You see that red? I know, it's hard. I'll try to get the glare out of the way.
There.
Yeah, you see it? So it's a sideways parabola, and it starts at 0. Okay? I know it's hard to see. 5,000. Yeah, that's what the scale said. So the range, this is what the graph looks like. Another great grapher, but you need the iPad or the computer. Actually, you can use something like an iPhone. You just go to the website desmos.com, and it has a really nice grapher on there. Very easy to use. So this is what the graph looks like. The domain, as Julia said, is from 0 to infinity. And somebody shout out the range. Very good. Negative infinity to positive infinity. Because we start here, we have points, 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 points forever. Okay. Any questions on 3? Number 4. Describe in words what the following function does to its input. Generally, x is an input when you're talking about a function. Whatever's inside the parentheses in function notation is the input. You could have multiple inputs, but it's one of them. Okay. Julia, again. In words, what does this function do to x?
Multiplies it by 3.
And that's it. Okay? It triples the input and takes away 2, which is essentially what Julia said. I just chose different words. You can think of functions as number machines. And if you study engineering, you find out that a lot of applications of functions are to describe actual machines or actual physical processes with some type of mathematical equation. Okay? So it's helpful in my experience to understand them as machines. So you've got this machine, and x comes in. That x gets multiplied by 3, and then you get you subtract 2, and that is what comes out as well. Okay. Any questions on 4? Good. 5. Amber. We have a definition of f of x and g of x and h of x. Could you tell me how to find f of 2?
Okay, well, I just said f of 2 equals 2 times 2, so f of 2 equals 4.
Yep, you're just substituting. Every time you see x in the function definition, replace it with whatever's in the parentheses here. So the value of this function at x equals 2 is 4. So, Amber, from that, what do you know is a point on this function's graph?
Wait, what?
Based on what you just found, what do you know must be a point on the graph f of x equals 2x?
2, 4.
Excellent. Very nice. Another random person, Celine. Could you tell me how to find g of negative 3? And you get? Yes. Correct. Yep, becomes 10 plus 3. And Celine, that means that what is a point on g of x's graph? Same question I asked Amber. It has to have an x and a y. Negative 3 comma 13. Very good. Val, please tell me how to find h of negative 4. Yes? Okay. No. So negative 4 as a quantity times negative 4 is what? Positive 16. Okay. Then you have to apply this negative.
I said negative 16.
Negative 6.
I have...
Negative 6? I'm sorry.
Okay. Any questions on C? You don't have to have a number inside the parentheses, like we have in letter D. So, Terry, how do you think you could do letter D?
3 times 10 minus x.
Very good. So this is the same thing as saying f of 10 minus x, which is saying that everywhere you see x in f, you replace it with 10 minus x. If you can do substitution, you can evaluate functions. And Terry, what does that equal to?
20 minus 2x.
Good.
How come we don't solve for x?
We're not asked to solve for anything here. Like, you don't see an equal sign in any of these problems, right? So there's no solving, we're just evaluating and simplifying. And Nikki B, could you tell us how to find h of g of x? Letter E, 5E.
Okay, so you do negative x squared, and then inside that, you replace the x with 2x. So negative 2x squared.
No, it's not h of f of x. It's h of g of x. So you're not involving 2x.
So this is too complicated for me. Sorry.
Well, we're here to learn. So what I recommend is replace g of x with what it stands for. Do you see how it stands for 10 minus x?
Yeah.
Okay. So it's h of 10 minus x now. Does that help in any way?
So then negative x squared.
Yep, you're going to use that, but you're going to replace the x with what's inside the parentheses here. It's just substitution. So everywhere you see x in this function h, you'll replace it with 10 minus x. The x here, it just stands for an input. It's like a placeholder. Okay? And Nikki B, do you know how to simplify that expression?
Yeah, you have to FOIL.
Good.
Okay, so it's 100. Wait.
100?
Okay.
Yep, I'm with you.
Minus 10x
Mm-hmm.
minus 10x
Mm-hmm.
plus x squared.
Good. Keep going.
So then you put inside to 100 minus 20x plus x squared.
Good.
And then distribute the negative. So it's negative 100 plus 20x minus x squared.
Yeah. Good. You did it. So you just might need to practice that some more so you can do it on your own. Negative 100 plus 20x minus x squared, you could also write it in a different order. Any questions on letter E? If there's something that you can't see on the TV, just let me know because I can put books underneath to make it larger. Okay, now we're going to use this graph. For those of you who have taken the SAT or who are preparing for the SAT, know that these types of questions are on it. Functions. So it will help in that regard as well. Sue, could you tell us how to find f of negative 3, or to at least approximate it, using this graph? What's that? Okay, so I'll help you out. This is the x value here, negative 3. This is the graph of the function f of x. So what we do is we find negative 3 on the x-axis, and we get the corresponding y value. So we see where it connects with the graph. So do you see how it connects right here on the x-axis? So Sue, what's the y-coordinate here? 0. So that's your answer. Okay, the outputs of these things are y-coordinates, and what you're given inside is the x. Ali, could you tell us how to find f of 0? Good? Yep. Yeah. Okay. Good. Looks like it's 6. All right, Dominique, letter C. How can we find what approximate values of x is f of x equal to 5 from the graph? Okay, thank you for your honesty. We're trying to root out any misunderstandings here. So you're told that f of x equals 5. That's another way of saying that y equals 5. So you want to know what x values is the function equal to 5. So find out where the function crosses this line. Here's the trickier part. You have to go down to the x-axis to figure out what those values are. And I just said approximate. So what's an approximate value of this x value? Negative 2.5 maybe. Okay. And Dominique, how about this one? Maybe 1/4. And lastly, sure.
That's squiggly line meant to present repeat.
Please repeat.
The squiggly line is meant to be like and.
Correct.
And
It's the ish line.
can you use decimals?
Decimals?
Yes.
Decimals are acceptable. Yeah. Any questions on 6A through C? What I recommend is anything that presents you difficulty, I would circle it, try it again. You can print this off of our group, blank sheet, see if you can do it on your own. You also have textbook problems that relate. And find somebody who can help you, either me, a peer, someone. Good. Gabe, using this graph, how many units of the drug are in the bloodstream at 8 hours?
I'm going to go with 24 units.
Okay. So tell us how you got that.
Well, I looked at the graph. I looked where 8 is,
Mm-hmm.
the 8-hour mark.
Mm-hmm.
And then I saw the scale on the Y
Mm-hmm.
was like 4 at a time. And then I just measured it out.
Yeah. So as you can see, you have 16 on the y-axis here, and 1, 2, 3, 4 boxes. So 16 divided by 4 is 4. So we're going in 4s. So this will be 20 and then 24. Good. So know how to deal with different scalings. So as you can see, math used in medicine or pharmacology. What is New Jersey's #1 industry?
Pharmaceutical.
Pharmaceuticals.
How did I get it?
Drugs. Dan, letter B. Could you tell us during what time interval the drug level is increasing? 0 to 2 hours. And can you describe how you got 2? Yeah. Look for the peak. That's where it stops increasing. And that x value is halfway between 0 and 4, which is obviously 2. And Nakia, during what time interval is the drug level decreasing? 2 to 12, or maybe 2 to infinity.
Well, eventually, wouldn't it be eventually, or
Yes, now you get into the realm of what is practical. It's like with Half-Life. So, does anyone know what Half-Life is?
radioactive stuff?
Not the video game.
Like a radio.
Terry, that amuses me that that's what you were
What did he say?
referring to.
When
Okay.
something decays to half the amount it was before, radioactively.
So half-life is the amount of time it takes for a substance to decay such that only half of its original amount remains. And that is used with pharmaceuticals. So you could have a half-life, let's say, of 2 hours. That means once you take the pill, for example, there's half of that substance left in your bloodstream 2 hours later. Then, after 4 hours, how much is left? Nope. A quarter. Okay, so after every half-life, it's half of what was previous. Now, the reason I bring this up is because theoretically, the drug never leaves your system. It's like Zeno's paradox. Anyone familiar with that?
Of course.
No? So Zeno was an ancient Greek philosopher, and he had this conundrum.
What?
Conundrum.
Question.
Like a dilemma, something that was confusing. And he said, all right, if you've got this person who's trying to make it to this wall, and every step he takes is half the distance to the wall, like for example, you know, the next time he walks, he's here. Well, the next step is half the distance again, so now he's here. Hopefully you can realize that he will never reach the wall.
That's awful.
Okay?
Well, basically, it does.
But in physical reality, we know that runners can reach walls. Okay? So this is an example of the conflict between what's happening in theory, conceptually, and reality. Okay? So with half-life, the substance technically or theoretically never leaves your system because it's always halving. But in reality, it does eventually leave the system completely. Okay? Good. Next random person. Jen. When does the level of the drug... We'll come back to you. Yunjae, when does the level of the drug reach its maximum value? At 2 hours. And how many units are in the bloodstream at that time? Okay, it's 64. Okay, Nikki S. out on an excursion. Nick, when the drug reaches its max level in the bloodstream, how many additional hours are required for the level to drop to 16 units? Okay. And could you describe your method? Mm-hmm. Okay, so here's 16. And Nick, what's this point here? 10. And the peak is at 2. So the difference between 2 and 10 is 8 hours. Good. And I think we have, okay, just a couple more. All right, Jen, you were called upon when you came in, so let's do number 8. In the following imaginary function, grade of tests, quizzes, class participation, and homework, blah, 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 what are the independent variables? Okay. So the independent variables are the ones on the inside of the parentheses. They're the ones that can do whatever they want. Like your test scores, they're going to do something. Their quizzes are going to do something. The grade is dependent on those things. So the grade is the dependent variable, and then the tests, quizzes, class participation, and homework are the independent variables. Okay, last one. Jessica, were you able to come up with a function to match this pattern? We'll just call it F. Okay, I'll go to a volunteer. Anyone able to come up with a function?
I want to distribute.
Gabe?
So I basically I saw the way it increased by, well, every one x value that went up went by 2 for the y value.
Yes. Goes up by 2 every time.
And the slope of 2 over 1.
I agree.
And
Slope is 2.
And since the y-intercept is 2, I said plus 2 afterwards. So I ended up getting 2x plus 2 as the equation. 100 game.
That's in the video.
I feel proud.
Any questions?
Yeah.
Question.
What if you're not given the y-intercept?
Excellent question.
Yeah, you are.
Okay, we're given the y-intercept here because we have an x-coordinate of 0. If you're not given the y-intercept, what you can do is you can solve for it. So let's remove the 0, 2 and work with the 1, 4. So the y value is 4. You know the slope is 2. You plug in 1 for the x value, and then you solve for the y-intercept. Okay, and you'll get 2. There are other ways to do it that don't involve such a strict attachment to a line. But I like Gabe's way, especially because it wasn't what I thought of. And I like when my students teach me things that I'm not aware of.
What do you think?
What were you?
I was just like, what's happening to the x to get to y every time? So like if I just look at this, I could say, oh, maybe we add 2. But that doesn't work here, so I try again.
That's what I did.
Yeah, I was like, all right, well, it looks like I basically just guess. You know, I say, well, let's see what happens. If I multiply it by 2, no, because 2 times 2 is 4. But that kind of works because I just need to add 2. I do also what Gabe did, looking at the change in the y every time, because that can tell you what the multiplier is. It's meant to be a challenging question, a critical thinking question.